Ok, on
Okay,
commence.
and I think it's launched. Hello everyone. We will wait a few minutes for people to connect. I'll just check it's working on LinkedIn, YouTube, and maybe some people are on Twitch. If you are connected and you hear us, can you please put a comment so that we see that some people are there?
Tell us where you're logging in from.
Okay, seems to work on YouTube. It works as well on LinkedIn. And I see 20 people on LinkedIn. Okay, perfect. People from New York, Paris, Montreal, Vancouver. Perfect. Okay, great. Thanks everyone. So I think we are at least 30 people connected right now, maybe a bit more connecting. I think we'll start in 1 minute. People from Luxembourg, LA, Paris again.
That's so exciting.
Okay, great. We can start. To introduce myself, I'm Theo Alves da Costa. I'm co-president of the NGO Data for Good. Sasha.
Hi, everyone. I'm Sasha. I'm the AI and climate lead at Hugging Face.
And hi everyone, I'm Juliette. I work at the French Ministry of Environment on everything related to AI, and I'm particularly involved in the organization of the AI Action Summit that is coming up in February 2025, in 3 weeks now.
And together we're the co-organizers of the Frugal AI Challenge.
So we have planned a webinar with many things today. We have a short introduction by Juliette about the challenge, the AI Action Summit, the sustainable AI part of the summit. We'll talk about the challenge itself, explaining what is behind, what are the tasks, and some super concrete stuff on how to submit, participate, and what we can expect from it. And I think after that, we'll have lots of time for Q&As if you want. Juliette, up to you.
Well, thank you very much. I'll start by giving some context about the AI Action Summit. So, for those who didn't hear about it, this AI Action Summit is happening after the AI Safety Summits that occurred in Bletchley Park in Seoul in November 2023 and May 2024. Those AI Safety Summits were really focused on the issue of the safety of AI, as it says. But here, this AI Action Summit is broader in topics, and the main objective is to talk about the commons that we need to build trust and steer AI towards beneficial impacts. And there are 3 key areas that are going to be talked about during this summit: open and inclusive AI, inclusive and coordinated AI governance, and the sustainability of AI in general for people, societies, and the planet will also be discussed. On this, so there's sustainable AI for people, but we're focusing here on my part on sustainable AI for the planet. And so on the next slides, well, this topic is really about ensuring that AI is beneficial and compatible with our environmental goals by encouraging more science, standards, and solution. So it's looking both at how we can use AI for the environmental transition and how we can make the most of it, but also how we can think about its impacts and get more science, more knowledge on its environmental impact and the technologies and best practices to reduce it. Also, how we can agree on methodologies to measure and reduce AI environmental impact. This is still a big topic. Right now, we have very few numbers, and the numbers that we get are not really comparable because we don't have shared methodologies. And the final one is the solutions, the lower impact data centers, the more frugal models, and the AI models that can be beneficial to our environmental goals. We started several initiatives for this AI Action Summit with several stakeholders, companies, associations, research institutes, governments, and international organizations to bring more, like I said, science standard solutions. And in the end, we decided that all these things that we started before the summit should continue for the future AA summits, also for the future COPs or all the international gatherings that are going to happen in the next months and years around environment or around AI. So we decided to build for this summit a community of stakeholders that are committed to deliver and share science solutions and standards guiding AI development and deployment in alignment with climate commitments and sustainability goals, and to make sure that all the initiatives that are starting right now, that have started in the last months or that will start later, they connect to each other so that we make sure that they are not fragmented or they not duplicate with each other. So the objective for this coalition is to bring together the researchers, industry leaders, international decision makers, and NGOs and the general public that want to work on this and identify the relevant workflows and stakeholders ready to address this issue and continue what we already started during the summits. On the next slide. So the summit timeline, for those who haven't heard about it, the first days are going to be the science days or the scientific days. It will be specifically with researchers. It will be in the Institut Polytechnique de Paris for 2 days. You can look at the event online. Everything is online, and I'll share the links later. During the weekend, on the 8th and the 9th, there will be the cultural events at key spots in Paris, the BNF and the Conciergerie, so that everyone is able to see use cases of AI for culture, and there will be other public events during this weekend. And the big days, I would say, of the summit are the 10th and the 11th. And on the 11th, we are organizing at the French Ministry of Environment a forum for sustainable AI. It's the next slide. And that is, so it's at the headquarters of the Ministry of the Ecological Transitions on February 11th. And there we will present the winners of this challenge, actually, the challenge that we will present. But if you're here, you know about this challenge already. And you'll have some time to pitch your solution for this challenge. And also you'll have a booth to present your solution during the event, where 200 people from international organizations, governments, companies, association will gather. That's it for me. I think,
All right.
Sasha.
Yes, my turn. So the challenge itself. Next slide. We will. Oh yeah. So frugality is really at the center of it. Why frugality? Why now in AI? So I mean, as many of you know, I mean, we're living a climate crisis, and especially in terms of natural resources. Energy, for example, has really been at the forefront, but also water usage, all of that is becoming more and more precious. And so thinking about frugality, thinking about responsible use of those resources and how to make sure that we are training and deploying AI models with that in mind is going to come increasingly important. And also this question of what AI can enable, what kind of problems AI can enable to solve, because it's true that there are lots of climate positive applications out there. It's true that AI can help, improve climate modeling, can track biodiversity, et cetera, but we need to make trade-offs with regards to costs and benefits. And while generally speaking in AI in the recent years, there's been really an emphasis on bigger is better. So bigger models with more parameters perform better. This is not always the case for all applications and across all ways of evaluating. And so what kind of we advocate for is thinking about eco-design practices, thinking about existing. And this is not a new question. People have been thinking about it for a while. So applying these practices in digital service deployment design, and also set up ways of measuring, tracking the consumption of these resources are important. Next slide. So we have 3 tasks. I'll go through we wanted to cover as many modalities as possible. So one is text, one is image, and one is audio. And I'll go through them quickly because many of you already probably know. Next slide. So the first one is detecting climate change misinformation. I was actually just talking about this topic with a reporter the other day. It's actually really hard to detect climate change misinformation in the media, in the news, because there's all these different ways in which you can negate the climate crisis, diminish it. And so we partnered up with some NGOs and they provided us with labeled data, with a taxonomy, with a classification of claims, of climate denial claims that we're using as the task. And it's a lot more complicated than just binary, is this true, is this false? But there's really a taxonomy behind it about why is this misinformation? So that's the text classification task. Next slide. The image one is provided by Pyroneer, which is also an NGO in France that tries to detect forest fires before they happen, before they get out of hand. And so they have CCTV cameras that they capture these kinds of plumes of smoke. And the goal is really to train models that are capable of locating these plumes as early as possible so that you can deploy firefighters and resources before things get out of hand. And next slide. And the last slide, the last task is audio classification with a partner called Rainforest Connection, and they've been working for several years now. And they have these devices, they call them guardians, that are deployed in the jungles of South America and Southeast Asia. And essentially, they listen to the sounds of the rainforest, and they try to detect illegal logging, which is invisible from space, which is really hard to detect. But if you have these small devices that listen to the rainforest, they can really trigger alarms. And so rangers get sent out to make sure that the people who are chopping down trees stop chopping down trees. Thing 2 now. Yes.
Yes. So we have opened the challenge like 2 weeks ago, I think. We already have some participants, but it's a good opportunity for us also to share how to participate, what we will do with those submissions, how we will rank them, and how we will restitute the results in the coming weeks. So I will explain that. Basically, first, how to participate. Everything is within, and I will put the links in the chat, and also by email. You can also subscribe to the newsletter to get the latest news. But basically, and that's when it becomes also geeky so if you are connected and you are not especially a tech person, please bear with me, because there will be a few minutes where I will explain how to, like, developers, data scientists, and researchers can participate. But basically, you need to get the template that we provided that will help you guide through all of the process to participate in the challenge. You have notebooks in Python to actually iterate for each task, where everything is already set up to evaluate, to get the data, to actually have already a first baseline on which you can tinker with, so that you can actually change the code and try to see what works. But also something really important that is actually shown here in this code, which is the tracker, that is code provided by also a library and an NGO called Code Carbon, that is able to measure the code and the carbon footprint and the energy consumption of the code that you are running on a specific hardware. And so with all of this, you can actually play with the task and try to solve them in both performance and efficiency. Then, when you think that you have developed something super intelligent, maybe efficient, then the goal is to actually deploy and make a submission. Why we have that is compared to maybe some people that are connected are already doing some Kaggle challenges or some machine learning competitions, and then you actually submit a prediction. For us, it's a bit different because we don't need just a prediction. We also want to compute the energy consumption. So we don't need just a spreadsheet with the predictions. We actually need the model itself. And what we will do after the end of the challenge, we will take the model and we will recompute on the hidden test set so that we can actually measure the energy consumption on the same hardware to be sure that we can actually compare apples to apples and to compare the different options in the same setting. And so what we are actually asking for the users is to use this template to deploy the model so that we can actually run it on something else. And it's also a good exercise to think that in a real world task, you actually need to deploy it in an environment. And so we have already set up another template that all of the documentation is provided to actually put your code at the right place so that you can deploy your API and your model within Hugging Face. Then you can test it, you can be sure that it works, and then you can actually submit your results within the portal. So there is a portal there where you can actually say, okay, this is my model, it's there. I want to participate to the text challenge and you can evaluate and submit it so that we can actually know that you participated and already give us some really interesting information. I will speak about that in a few minutes. Then we are actually asking to fill another form when you have participated and you are actually quite proud of your results, just for the simple thing that if you are in Paris in February, if you win, we actually need a bit more information to be sure that maybe you are invited and maybe you can participate if it's possible. And so there's a last step that to provide and to fill this form when you are the last step and you want to participate. Everything is documented in this slide, but also already during in the participate page of the challenge that I will put in the chat just after this presentation. But having all of those steps, you will be able to participate, play with it, and then submit your results. What do we do with it? We evaluate and we try to see and to learn from it. So I will try to explain that in a few minutes. What we do is that we have a hidden test set. So what does it mean is that we have hidden some of the data points where we actually have the answer for each task that only us have access. And your goal is to beat the accuracy threshold that we put for each data set while actually minimizing for energy consumption. Otherwise, it won't be a frugality challenge. And the baseline for each accuracy threshold is to beat 90% for each algorithm, each model to be useful on each task. 90% is the baseline that we saw that was both interesting and feasible from the first benchmarks that we got. Having said that, what we will do between the 31st of January and the 11th of February, we will run that on our side privately on small GPUs so to actually measure for performance on the test set, on the hidden test set, but also for the energy consumption on the same hardware. It will give some results like this. This is a first analysis. I think we had already 30 submissions before at the start of the challenge for the first 2 weeks. And you can see here, it's on a task. You can see in the y-axis, you can see the accuracy of the model. So do we detect accurately the type of climate disinformation? And on the x-axis, you see the energy consumed in watt hour. And you can see that the models are quite disparate in terms of performance and energy consumption. For example, we have this model that is called Evaluate Text Classification for Climate Disinformation that is actually consuming a lot of energy compared to the others, but beats the threshold of 90%. We also have some models that are not that bad. For example, in this part with simple model that do not consume a lot, but are still accurate, but and for example, here we have a cluster of models that we see with some fine-tuning of BERT model, a random forest overfitted like crazy, which was fun when we took a look at that. And those could be some interesting opportunities that could win the challenge at the end. One thing that we found is that some of the people who participated in the challenge probably have overfitted on the test set. So be sure that you're actually applying a right trend test split or a right evaluation data set before we actually compute that on a hidden test set. So here it's quite admitted that it was overfitted, but the other candidates that maybe did not work sufficiently well on the overfitting part. But that's the kind of benchmark that we'll be able to do, and on each task. And so what we will actually try after the challenge is to see what are all the learnings we can learn from it. For which type of task did we see that this type of model or this type of approach was working well and better when the goal was to reach a certain level of performance, but minimize as much as possible the energy consumption. And just to finish on this, how we will do concretely. Right now, we have all submissions. So we have around 30 of them for some of the tasks. And we will first rank on accuracy. We will take all of the submissions that beat the accuracy threshold of 90% for each task. Then we will rank on energy consumption, the top 10, which are the least energy consuming. And then we will apply a final ranking to see on each task which model or which approach is the winner, with a selection among the top 10 that are the least energy consuming. The selection will be done by a jury composed of technical and of experts also on the specific tasks. And that will help us also learn specifically from the model cards which approach was used. We will look also at model training, but also specifically because it's a real world task and we want to be super precise and not just a machine learning competition out of nowhere. We want also to see maybe some other metrics. For example, when you have a real world deployment in forests for deforestation or for forest fire, you don't want to be wrong on false positive, for example, because otherwise you send the firefighters and maybe there is no fire. So the accuracy itself is maybe not the only metric. So that's why we'll also take a look at some other metrics to see among the top submissions who are the ones that will be the best suitable in a real world task. So that's a complex evaluation approach. It's not just checking for accuracy, but that's also why we want to do it, is to show that for a real world problem on climate is not just accuracy. It needs to be also focused on frugality, but also on a real world application. Last slide, I think, and we'll have time for a lot of questions, and that's cool. Right now, we announced the challenge in November. We shared the data sets in December. The portal and the challenge itself is open until the 31st of January. So we still have more than 10 days to work on this. And then we will stop the submissions so that we can do an analysis between right now, the end of the challenge, and the submit. And we will announce the winners during the summit on the 11th of February. After that, we'll probably publish the analysis in a blog post or maybe in another webinar. We don't know yet, depending on the results that we have. But in any case, those challenges will be open even afterward. For example, if you are working in a school and you want to teach machine learning or whatever, it will always be available in open data and open source on Hugging Face. And I think that's it for the introduction.
The monologues. I think we have some questions in the chat.
Perfect. Do you see? Okay. How many? I can answer a few of them. How many participants actually? So we have 30 of more participants on the text. We have, I think, 10 or 15 on the audio task that have submitted, and I think only 5 on the image task that is maybe a bit more difficult, but that's not only accounting for the people that have submitted and do the full process, because we also saw that we also had maybe 30 or 40 participants that just cloned the repo to work privately before submitting. So right now we don't know yet, but that's an estimate that we have. A second question I can answer, of course, you will have a recording of the event. Actually, if you are on YouTube already, it will be the same link, but we will also send back the replay of the event so that everyone has access to it. Andre has two other questions.
Yes, the hidden test sets are all hidden. You cannot see them.
Yes, exactly.
So actually that's something that's worth stressing, right? So the evaluation that's currently set up is on the validation set that's public. So when you're training and testing your models, you can use, so Hugging Face datasets has these functionalities where essentially you're loading a dataset. You can say whether you want to use the train set or the training split rather, or the test split. And so essentially we are currently evaluating on those, but you don't know. I mean, the final performance may differ because it's the hidden test set. So that's why it is hidden, and you can't see it.
Yeah. And yes, Andre, we can also put the evaluation on the website. We actually made the baseline yesterday based on the first submissions, so it was super fresh, and we will update it on the website as well just after. Renato has a question on the image task, what the metric should be maximized. It's a really interesting one, and actually we will maximize on the accuracy as well. So that just the accuracy needs to be above 90%. Why do we have the other one? Is to have also other metrics. For example, IOU, if you estimate, so that means that you have also a good, you can frame where the fire is. And if you can estimate the depth from a camera in a picture, having a big fire that is super closed, it is helping to locate where are the fire and is it a big fire. So that's a metric that is really interesting to see if it's going well, but more for the application then when the firefighters would be intervening. And so it's not the real goal is to maximize first accuracy, and the IOU, it's another metric that is actually interesting to watch, but we will actually take a look only at accuracy.
And essentially for each of these tasks, what's interesting is that there isn't a single metric. I mean, we're using accuracy to give you a kind of a guiding kind of optimization framework. But of course, for each one of these partners, there are multiple things at play. So for example, if you have a lot of false positives and they're constantly sending firefighters or sending rangers to places that don't actually have fires or deforestation, that costs them money, right? These are harder to quantify, but it's interesting to think about them. And actually, when we're going to be presenting the results of the summit, we will kind of ask the partners to talk about like what really matters for them on the field and like how they're going to be implementing these things in practice.
Also, another important question is more a bug on our side about the timing out of the portal. It's a bug we saw that we actually deployed and invented the mini Kaggle on Hugging Face, which was the first. And we still see some other bugs. If the submission portal in itself, if people are using it at the same time, it can maybe queue. And sometimes if it fails, we have to rerun or restart the space. We are still correcting some mistakes, but if you have encountered that problem, you have two options. First, you can warn us by emails that we can restart it, even if we're still correcting sometimes a few bugs, and we are adding a queue to avoid it. But know that you can actually also just use the evaluation locally. It's the same as on the platform. You can just evaluate locally. You have all of the functions, and even you can clone the submission portal if you want to use it for evaluation, and then just submit it afterward when it works well. Even if you still encounter a problem, let's say that you have developed a super nice model and there is a bug on our side, we won't be authoritarian. Just send us an email with your information, your model, or whatever, and we'll try to make it work for you. And we will rerun that just after. Juliette, there is a question for you. about the Coalition for Sustainable AI, can we join the network even if we are not taking part in the challenge attending the summit? And if yes, how can we join and stay updated?
So the answer is yes. And actually, Theo, I'm not able to participate in the chat, but if you would be able to share the links that I just sent you, that would be perfect. You can
Yes,
reach out directly to our email for this, and we'll send you all the relevant documents for explanations and how to join.
yes. Okay, I'll put. So the first thing I'm putting is to access the events of the 11th. Will it be also broadcast online as well, or?
Probably this hasn't been put in place already, but so participation is first in person, and the link here is for the in-person participation. The number of participants is limited, so the link is if you register for this link, it's going to be subject to confirmation. We're going to look at your organization and make sure that there are not several people from the same organizations registering at the same time, so that we allow for a really diverse number of organizations to join. And yeah, I put the email for all the information related to the coalition, but it's outside the scope of this challenge, so I won't get into more details in this webinar.
Yeah. Let me also put in the chat the mailing list where you can be sure that you have all information about the challenge and the future projects we will build. Let me just put that before taking another question. So other questions that we add. Okay, one that was interesting also in terms of approach. Ashish is asking that, of course, machine learning typical models will be more efficient in terms of energy consumption, and we can get a good accuracy. And if we use foundational models or LLMs, it's almost sure that it will consume a bit more. And can we use and fine-tune foundation models if we quantize them to see if we can lower the energy consumed for these models? And of course, it's possible. We'd love to see also some other options where you take a bigger models and you compress it and you quantize it so that you can actually have a really low energy consumption model. It's a different approach that we'll love to see and to compare. As our goal is mostly to score the energy consumption on the inference part. Ideally, we'll look at the model cards that we can see the training part. So if you build a super big model and you train it for 70 weeks on a big cluster, maybe you will not be able to select you as a winner, but the real goal for us is actually to score on inference. So if you can actually use a foundation model and quantize it, we'd love to see this type of option. Another question, what about the risk of abusive optimization of evaluation function? Is it possible to have the same evaluation function for everyone? I'm not sure I will answer that well.
Well, I mean, it's kind of what we were talking about yesterday, right? Since we have the hidden test set, you can't optimize. You can't abuse the hidden test set because you don't have access to it. You can abuse the validation set all you want, but it's not going to help you necessarily with regards to the hidden test set.
And also, the goal for us is to run it on the same hardware as well. That's also why we're doing that. So at the end, we'll run it on the same GPUs, the same CPUs, so that everyone is compared the same way.
We had a couple of questions about hardware via email, actually, and people were like, oh, can we submit our own custom hardware that we've been working on? You know, we have a startup and blah, blah, blah. And I said, I responded to say that we are using the same GPUs. I mean, essentially, in order to help people do apples to apples comparisons, like otherwise, you know, some people are running on Raspberry Pis and some on A100 clusters, and it wouldn't be very fair. So we are gonna run all the models ourselves on the same GPUs, as Theo says.
And maybe, Sasha, it will be interesting also for the participants to learn about the AI energy score that maybe extend also this like thinking and approach. Maybe at some point you can explain it.
Yeah, actually, so it's one of the things that we are presenting and launching at the AI Action Summit in a couple of weeks is inspired by the Energy Star ratings or the energy scores. I think you call them in France. So the goal is really to compare models, AI models, for the same task and the same hardware and measure energy consumption. And instead of giving the raw numbers, giving a relative comparison, so a score essentially. And so this is one of the initiatives to help people kind of better understand energy efficiency and since there's no one size fits all task for AI, also to look at different tasks, because you can't really compare an image generation model in HD with a small text classification model.
I have some questions on the image task. I will answer that. And then just before, two organizational, let's say question. Is there a forum channel for the participants to discuss? That was the plan, and we don't have it yet, and we probably won't have it. I think for the French one, for the French speakers, and Lucas, I know you are in the Slack of Data for Good. I will create a Slack channel after this webinar for the French-speaking people, but we actually missed and failed to create a real forum channel to actually create this community. So right now it's mostly on Hugging Face and by mail. Super naive question: how difficult this challenge is technically? It's actually quite feasible. The text task can be solved in many different ways. The audio task is really interesting because that's a modality people don't usually work on, and by using a few tutorials, it's actually quite feasible. The image task is maybe the most difficult one. It's a bit more complex with different modalities predicting the bounding box and stuff, but it should be accessible even for a beginner. And that's also why we tried to make it the most easy for people to try. And you have a baseline, you can copy the code, you even have some examples and notebooks to actually participate. But please send us an email if you tried it and you still don't know. We'll try to make it our best so that you can actually try to participate.
Actually, to share my own personal experience, I've never worked on audio before, and I was trying some baselines in the last couple of days, essentially to get an idea of how hard it is. And there's a really good. I mean, once again, I'm biased, but Hugging Face has a good course, and then has a module on audio. So essentially, they have a Jupyter notebook where you can kind of essentially switch out the dataset name and then whatever model you want to start with, and it's fairly straightforward. So it took me a couple of hours, but I learned a lot about audio data and frequencies and things like that. So you actually have a little video and stuff. So that was helpful.
Let me re-put the link because it was the wrong link for the Sustainable AI event. Thanks, Charlotte, for pointing it out. So I put the right Eventbrite link. Okay. Share the details of the hardware config you'll be using. Correct me if I'm wrong, Sasha, but I think it's the smallest T4 that is available on Hugging Face.
Exactly.
So a small GPU.
If you wanna have an idea, on the Hugging Face spaces, for example, if you're cloning a space, you have a choice of backend, and essentially you can choose that one to get an idea already of what it looks like.
Then I see an interesting question about Luc. Can the context be open to non-computer inference? And meaning sound detection works well with edge computing, Raspberry Pico microcontrollers, not Raspberry Pi. In a way, why not? We would love to see and to compare different approaches, depending on if it's applicable to the existing setup of the NGO that proposed those tasks. So, for example, rainforest detection in the forest, they already have their materials that is set up. on the trees. And so if it doesn't mean changing the existing setup, but just a different approach, it's difficult to rank everyone the same way. But maybe send us an email with your proposition, because maybe we can actually include it in the report or that we will provide at the end of the analysis. Thibaut is saying, and I think Sasha, you will have the answer, that carbon emissions estimation with code carbon tend to show some variance depending on when it's run for the first time on Hugging Face. Is it planned for us to execute multiple runs to take an average so that we have a better estimation of the carbon footprint during evaluation?
We're evaluating energy. We're not, I mean, we can do extrapolations on carbon emissions, but the goal is really energy here. And that's what we're comparing. We're comparing kilowatt hours, not grams of CO2.
And even on energy, I think you're also used to, even on energy, to make it multiple times to average it.
Do at least 10 runs, but energy tends to be more solid.
Yes, Andre, it's the NVIDIA T4 Small, not the 0 GPU. We will also re-put the config of the hardware on the websites. Okay, do we miss? The evaluation function on IOU count. Okay, maybe there is a, I need to check. I think what you're saying about the image task, I need to check if it works well with what you're saying, but basically the real goal for the first part of the evaluation is just fire, not fire, as a really classification accuracy, depending on whether there is one or two bounding box. And then we'll take a look at the other metrics on IOU, recall, and precision for the last part of the challenge. But already having a classification algorithm that worked well is already super interesting for intervening for the firefighters. But still, maybe there is a problem with the evaluation function. I will check that. I'll copy those comments and just check that, and we'll send an email in that case.
Oh, speaking of emails, sign up for our mailing list if you haven't already. It's on our website. There's like a frame form because we've been sending updates. I think we have several hundred people, but we send updates. We send kind of, I don't know, information and things like that, which might be useful for you. And we'll send out. It's kind of our way of communicating with everyone. So we'll send out a link to the recording of the final event and things like that. So if you want to stay in touch.
Another interesting question is about water calculation, and Benoit from Code Carbon has answered that water impact is linked to energy, and that depends also on a data center. And so that's something that we don't have, unfortunately.
Yeah, water is a separate issue. I mean, they're all connected and emissions are connected and water is connected. But the thing is with water, actually, there's no good way of estimating it without information from the data center. As opposed to emissions, for example, you can try to estimate based on the energy grid. So for example, I'm in Montreal, we have a hydroelectric grid. So if a process is running here, you can pretty surely say that it's using the local energy grid with like a carbon intensity of X. But you have absolutely no information about water. So you can estimate based on very, very high level numbers, but there's no way of getting the exact number you would need. So we're not there yet.
Two other questions. That's really cool that we did not 1 hour long webinar and we have time for this. And that's also, I think, the goal for the three of us was also to create a community, and that's cool to see that all of you are super interested. Would we be interested in seeing our exploratory data analysis in the notebooks? For sure, the more precision that we have, especially if it means that then you took some choices that made a difference in terms of optimization, that's super interesting. because that's something that we can actually say when we say the bigger is better, and we just put all of the data and expect for training to last sufficiently long for the model to be good. If someone just says, okay, I understood the problem, I took a look at the data and I explored it, and then I made some super drastic choice that made me build a super simple model with a few features, and that works. For us, it's a really interesting learning that we can actually put forward. Maybe that doesn't mean that you will win the challenge, but that's maybe something we can put then in the final results, in the meta-analysis that we will build at the end.
We will be publishing like a blog post and updates on the website. And I think that we were just talking about this with Theo yesterday, that I mean, of course, the challenge is great. Challenges are great. Hackathons are great. But also the goal is to get more information. And like the plot that Theo showed on the slides, that was something that he generated himself based on, a couple of experiments and a couple of trial runs. But the more data we have about, things that work, we can also push back against the narrative that, I don't know, whatever. For example, only transformer type models are the best ones for text. Maybe somebody uses a bag of words and manages to get a great performance, right? And so I think that any information that we have about what you do, what didn't work, actually, I don't know if you followed along, but there are more and more workshops and places to present negative results. For example, in AI, which I find is really interesting because you tend not to hear about them, and so you can't learn from them as a community. And so even if you want to share some kind of failed experiments with us. Even if you, for example, don't beat the 90% benchmark, you can still submit a model and be like, hey, this is all the things that I tried, and I went from 40% to 85, but I haven't met the 90%, which is still completely valid and interesting and worth sharing.
I have a question on, can it be C++ instead of Python? I'd say that it will be difficult for us then to run the code. So again, maybe it's interesting for us to know about it. So if you want to test it and to maybe be promoted because it worked well and your approach was sufficiently interesting for us to know about it, for sure. But it will be too difficult for us to run all of those if it's not configured the same way. LinkedIn user is saying, indeed, it's great to talk about our gains and even more impactful to talk about our mistake. Did we answer everything?
Last chance to ask questions. Okay, I think we did. You can also send us emails if you want via the website. We have our email address and we'll answer them. And so just to clarify, so the submission ends on the 31st at midnight anywhere on Earth time, which is kind of the fictional time zone that has been invented. I think it's almost like 1 p.m. French time, or like European time. It would be actually the 1st of February, but 31st of January anywhere on Earth. And we're going to take those 10 days to run the evaluations, to do a write-up, to kind of look at all your submissions, and then let people know as well. So
okay,
there's one question from Thibaut. Yeah, the hidden test sets are just, so we essentially did random sampling from the same data set, and we created a train set, a validation set, and a hidden test set. So same sampling, same data format, same everything. They're same labels, same distribution.
Perfect. I guess we have answered all of the questions. Thank you so much. It's really cool that we had all of those questions and this interest. I think what will be really interesting for us is, as Sasha said, even if you don't make it as the winner, just getting data on this type of issues is really interesting for all of us as a community when we work on those topics. So even if your model is not the best one, but your approach is interesting, that's great for us. So even if you're a beginner, you should be able to participate, and all of the data will be useful. So thank you everyone for participating.
Have a great end of day.
Thank you all for your participation.